I'll go ahead and start recording too for the DE. Huh? Yeah. Yeah, for the DE students, you guys need to know a couple of things. So now I'm talking to these guys, okay? But you need to know a couple of things. I messed up this computer really bad. That's why it's going to be such a short uh, presentation today. Um, getting to the stuff we need as quickly as I can. Some of you have asked questions about when I say something in here about lab. Uh, when I say something about the lab, that is just for the on-campus students. I have um, requested that I could teach the uh, online labs this summer, but I don't know yet if I'm going to get to. But I am going to try so that they will be these same labs that these guys are doing. The other thing I wanted to say real quick is if you have homework and you know um, you've got a few wrong, I really, really, really do not want to hear these full explanations of why you think one of your answers is right. Uh, just tell me which one you want me to look at, and I'll try to make that decision. Okay, now back for everybody. Uh, and the DE folks, the on-campus folks, got to hear a lot of great stories, and a couple of them called me an asshole right in front of everybody. Just thought you'd like to know. But these are difficult. They're coming up. These I've got some really weird ways of doing this, so I'm going to ask you all to hold up until I can get those fixed. And I'm going to do my best to start on that tomorrow, and maybe Thursday, but then Friday, Saturday, Sunday, I'm going to be out of town. And if I can, I'll work with them some. But anyhow, I'm not going to go into telling you why these are so weird. I'll fix them. I had also told them that any of these in the TTL that had errors in them, or for the resistors, go ahead and ask me to look at it. It could be that you were close enough uh, to the right answer that I would give you credit for it. Okay, let's look at these for a minute. You got Boolean logic. This one, if I'm not mistaken, I think it's just asking simple questions like, well, let's see what it's like. Okay, these are, assume this is all A, and we're doing a bitwise operation. So this is like you're in the microprocessor course. You've got not A, which means that's 0011. I'm sorry, I have to do something like this so that we can all see what we're doing. Okay, where's a word? Okay, I'll bring that. Damn, I'm not having the best day. I haven't fallen and hurt myself yet. Uh, you should have seen me yesterday. I was doing that all the time. So my A is 1100, and this up here says enter the bit pattern that represents not A and not B. So if this is A, then not A, and this here, this way of writing that is standard VHDL. This is 0011. And then B, I have, look at that. I said 0011, didn't I? And I wrote the opposite. The other one, not B, is, or I'm sorry, B is 0101, and not B. You guys might probably, a lot of you having younger brains than mine, probably are a lot smarter and you don't need to do all this. But I do. I write this down the way here's A, and then I write down here's not A. Here's B, here's not B. And then I can look at these and say, okay, let's AND these together. 1 and 0 is 0. Okay? 1 and 1 is a 1. 0 and 0 is a 0. And 0 and 1 is a 0. So that should be my answer. Okay? So all you put up in here, it says 4 numbers only, no spaces. You should put in 0010. How easy would that be to put in the wrong value? So easy, right? Just so easy. And there's only 10 of them. Again, here's a longer number and do not A and not B. Here's one that says just, I've given you A and B, but it says only enter not A. So here, am I not glad I wrote something down? Because I wrote down earlier, here's not A, right? So all I have to do is go 0011. I got that one because I've written it down somewhere. Here is A nor B. So here again, A and B are the ones that we're looking at. And it says A nor B. Well, what's the truth table for NOR? It's 1000 for the outputs, right? You got 00. Oops, where did I put that? That's not where I want it. Down here. I've got 00 inputs. There'd be 1 at the output. 0, 1, and there would be 0, right? 1, 0. What's it doing? It's changing my numbers too, isn't it? Damn word. Okay, forget it. Let's just get back here. So we're looking at A just the way it is, and then we've got B just the way it is. And an OR gate says that either one of them has to be 1, and you'll get a 1 on the output. A NOR gate says both inputs have to be 0 for your output to be high. So for this one, we should get 0010. Okay? Is that all right? Okay, so that should tell you what's going on there. Now I'm going to go ahead and finish it, and it's going to go, boy, you're stupid. You only got 2 out of something or other. And, no, not to the attempt. I'm sorry, I didn't mean to do that. I guess if I would slow down for a second and read, submit all and finish. Okay, I didn't get a very good score here. Ooh, the 2 I entered I got right. That's good. Okay, let's go back here. Not Boolean logic. Let's go back 1 to, where is it? Guess we have to go all the way back there. One of these is going to be probably, I think, the hardest quiz you're going to have out of all of them. What is taking so long? Come on. Come on, I'm behind. It's my fault. I want this to make up for it. Boolean reduction. This one, I mean, you do this however you want, but you know that there's some out there, equations that are for DE students, write it down. Something that might say X or XY. And that doesn't look a lot of times like it can be simplified, but X or X and Y can be reduced to Y. Okay? So there's going to be a lot of those little things in there that are hard to find. And I want you to take these to their simplest SOP form. Their simplest. I'm sorry?
Well, it's the B, it's the, you have to write it down now. It's not B and not C.
Yeah, I'm going to show you how we do that right here. So here it says reduce this to its simplest form. Now, I don't care if you use Boolean algebra. In fact, this one here is going to be hard because first thing you have to do, it's in POS form. I hope you didn't get this one. But in POS form, you first got to change it to SOP. And that's a lot of maneuvering. Okay, so let's move down and find one that's not so hard on my old brain. Let's take this one. Okay, so we get this, and if we have A not or A and not B, that does reduce, doesn't it? Or does it not? It does reduce. Let's go back to okay, y'all. If you're yapping, keep it a little bit lower. I can hear it. If I can hear it, it's too loud, and it's very distracting for me. I guess they didn't hear it. They were talking too loud. Shh. Okay, it should be in here somewhere. I know a couple of those were in there. Look at, have these right in front of you, okay? There's no reason not to. I didn't put anywhere in there that that this was not allowed. You can do this. And I thought there was some.
I think that's why mine canceled itself out.
There,
two of them open at once.
there's some of them in here. Wait a minute, where are they? Okay, here's like X and X or Y is X, and X or X not Y, or Y is X. And boy, I can mix those up where an X would equal AB and a Y would equal CDE or something like that. And you would, so it'd be AB or AB and CDE. And it would become AB. So you might have to reduce some of this in the other way. There is a way for absorption with the one I thought we saw, A naught, and okay, there should be some way to reduce this. I'm not seeing it. If we did it in a K-map, that I know reduces, and my brain's not working on it today. I thought this reduced to A naught, B naught, A naught or B naught. Does it not? Does anybody have anything that'll tell you right away? Is that right? I'm pretty sure this turns into A naught, B naught. Okay, I know the DE students can't see me, but I'm going to try this. Well, no, we'll do it this way, so maybe you can see me. I'm going to do a small Boolean, or I'm sorry, a small K-map that you can't actually see the lines for the K-map. But if we had A naught in a K-map that was the first two columns were A naught and the second two columns were A, then I would have a 1 here and a 1 here. And in and then for A, B naught, A would be this column, and B naught would just be this one right here. And so this one would be a 0. Is there any way for that to reduce? It looks like it's A naught, B naught, just like I was saying a minute ago. This is the same as these two right here. I'll circle them if I can find the little thing for drawing. Here it is. Insert shapes. So let's do a circle. This and shape outline. We'll have it like this, and shape. Oh, I'm sorry. Shape fill is none. And then the other one, we look at these two, and they're them, and we'll say the shape fill is there, and
No, put none.
I forgot to hit none, and shape outline something else. Okay, so these two in a K-map would be A. I'm sorry, they would be not A. And the other would be or, and then we look at the top line, that would be not B. Okay? So this one right here, that one's hard to see it, that it is. The only reason I noticed it was because I've worked with this for a long time. And I've seen these a lot. So I know that they exist, and you got to watch out for them. So if we reduce just this part, it'll reduce to A naught, B naught. And then we've got the not B and BC. And what should that reduce to then? It's the same kind of thing we have here, but it's going to reduce to not B and C, or not B or C. Do you see where that's? You want me to do it again on the K-map? But it should be not B or C. So our whole equation should be not A or not B or C. So now one way to write the expression in VHDL format, the proper way to do it would be X equals, you should have some parentheses here and say not A or parentheses not B or, and then the last one would be C. Now, it doesn't really care about capitals or not capitals. I always put my variables usually capital and the other words is not capitalized. Problem, pay attention to this. This is real important. I did two things in the answers. And if you want, I can go back and fix it up so it'll read this, but it probably won't happen until after you've already finished them. But what I did for the answer was just said what I put into Moodle. Well, let's say I want to edit the question. What I put in was not A or not B or C, no parentheses. So if we come down here, we see that there was my question. I said, here's the answer, not A or not B or C. And I said there were none others. Okay, so I could change this now, but Boolean has a little, or Moodle has a little fit when I do that kind of stuff. So anyhow, even though, oh, it wiped it out. How do you like that? Even though it didn't really like it, the right answer should be, you don't have to say X equal, but it should be not A or not B, and you don't need the parentheses around a single variable or C. And they should all end in a semicolon. So can you see where you're going to have a lot of them that are right and it's going to get marked wrong? Because Moodle just looks at this as text, and you're going to have one piece of text. If you had C space, even though Xilinx would take it and it would be all right, Moodle's going to count it wrong. If you like to put spaces between your parentheses, and it's going to count it wrong. So don't waste a lot of time on it. Type in your answers, and then if you don't, if you think what I gave you, if you can see that they're about the same, tell me to go look at it and I'll fix it.
Is that a colon or semicolon?
Huh?
At the end, do you have to put a colon or semicolon?
You are supposed to put a semicolon on the end. And let's see if I did it in here. I didn't do it in here. So I should have these, honestly, I should have them in the correct way so that you would be used to doing that by the time we got to VHDL. These I made up a couple years ago. One year I was out on medical leave. They found out I do have a brain, but they couldn't figure out if anything was moving. So they don't know for sure what's going on in there. But I just haven't had a chance to fix it. And by the time you get in there, I'm not going to have it fixed. This one here, Boolean manipulation, is the hardest quiz I think I've ever come up with. Okay, so they're all exactly like this. I've got this crazy looking thing over here, and I'll say equal to this. That's either a true or a false statement. So you don't necessarily reduce this down to the simplest equation. And I would get you all if I had just written something simple as not A or AB is equal to not A or B. You'd all said, nah, that ain't right. But that one would have been right. Here, this not AB or C, not A, or the B, not BC equals A, not B, or not A, not B. It's hard to tell, but you'll have to maneuver them and see if they're going to be equal. Now, sometimes, I'm sorry for this, but sometimes you can see the variables very clearly that each have a bar over them, and other times where you can't tell if it's a bar over both or if it's a bar for over each one. Write down as you're working on them what you were assuming. Okay. Number 2, I assumed that bar was over, there was 1 over A and there was 1 over B, and then work out your problem. Okay. Then if it's wrong, you got that little note, you can tell me and I can look at it and I'd go, I can see why he would do that. Okay, so you go on through these, and some of them get pretty messy. Of course, if you do all the other homework and you say, you know what, I just do not have the energy to do this, just put in 1K all the way down and say I'm done. This one, is it true? It's so close, right? I think it's false. Okay. Anyway, okay, that's those. I'm getting all these bad grades out there, but I can go out and wipe out my own grades. Okay. I hope that helps you along for the DE students. I'll try to help you along a little better as we can. We were in, I pulled this up because I couldn't remember which presentation we were on. Which ones have we done? If we did this, we haven't started optimization and hazard protection. Okay, that's 1, 2, 3, 4, 5. That one we can go a little bit. It's not going to hurt us. I know we only got a few more minutes, but let's go ahead and see what we can come up with. What happened to my presentations? There they are. T3. optimization and hazard protection. Wrong one. What? What? What is it doing? All right. Um. After all that, this isn't gonna work. Well, they put that in the wrong. I put it in the wrong machine. I was gonna blame those other guys. That was my fault. I put it in the wrong machine. It's still not working. Once more. I like my clicker, and just like all of us, if you saw the clicker across the room right next to the TV and you wanted to change the channel, you'd get up, walk over there, get the clicker, go back and sit down and change the channel, right? Okay, my clicker, oh, now it's going to work. Okay, excuse me. We're going to look at some variables or some K-maps here. Most likely, you're not going to have seen too many that where you enter the variables into the K-map. We're not going to get to that one today. But you can enter the variables into the K-map. It keeps you from having to put in, like if you have A, B, C, D, E, that means you should have 4 by 4 K-maps stacked on top of each other. I don't want to go three-dimensional, do you? I mean, not in K-maps and the rest of the world, yeah, but K-maps, no. So we could put E in the map, and it will, we'll show how to do that, and it simplifies it. So you can use larger expressions than usual in K-maps. The main reason we're going to do this is two big reasons. Actually, there's three main reasons for this. One is the entering variables on the K-maps. Two is to be able to spot those places where we have a potential race to the end for the answer. And we can eliminate them there, because otherwise we'll get a spike or a potential spike in our output waveform. Have any of you seen that yet in your digital stuff? Seen spikes in the output? Well, we can eliminate them. And we should know how to use K-maps as a way to reduce our functions to the lowest or the simplest form. Most of you have done this before. If you're like UNCC, it's been a year since you've seen it. If you're from the community college, it's been at least a year since you've seen it. And if you went to the community college and then went and worked somewhere for a couple years and then came back to school, it's been even longer since you've seen it. So there's no harm at all in reviewing some of this. Okay, here are some example K-maps. And I'm going to go to the next page too, but I'm going to come back. So we are going to look at the 2 variable, 3 variable, and the 4 variable. Up at the top, some people will call those a binary K-map, where it's showing where A is and where B is, and you may not put that little line up there. I do. I always have, always will. My teacher for digital was a long time ago. His name was Wine Glass, and we used to call him Beer Mug. And an old beer mug must have done that, And I swear he came in every class and said, okay, where were we? I know I do that sometimes too. I do that a lot. But he said, where were we? And somebody would speak up and say that we were like 2 or 3 sessions before. And he'd go, okay, so go up on the board and do this. And he never got off his butt. He never did a damn thing. My roommate at the time took the class and said, this is bullshit. I'm not doing this. I'm not going to take a class this way. So he refused to go back. And he refused to go through the motions to withdraw from the class. Now, at the time in the community colleges, they would just give you a W. He and I both made A's in that class. He went to 2 or 3 classes. I went to every one. Okay, so we got our binary ones. The columns are A, the rows are B. Okay. Over on the side, we've got A and B. We can see that A, B together could be 0, 0, or 0, 1, or 1, 1, or 1, 0. So when we're going to fill it out according to those binary numbers. Now, what's very important here is on these K-maps is as you move through this K-map and move from left to right, as you go from one cell to the next cell, only one variable can change. We're not allowed to move diagonally, but anytime that you move from one cell to another, only one variable's value can change. So if we look here at the top for A and B, this is A and B. A is this one right here, and B is that one because that's how they're arranged here. And I move from here to here. C is still 0 when I'm in this cell. A is still 0, but B changed to 1. Now I cannot go to 1, 0 here, because if I did, this would change to 1 and this one would change to 0. You can't do that. That's one of the rules of Carnot maps, and where people make their biggest mistakes. So it's 0, 0, 0, 1. We can't have 2 change, so it's 1, 1, and then go to 1, 0. From here to here, it's 0, 1. 0 and 1. If we had D, like we have here, we're going to do the same kind of thing as there. It's going to 0, 0, then 0, 1, 1, 1, and then 1, 0. Okay, from that, if you can remember that, you're doing great. Now we just can take these variables and say that this binary AB is a 0. This binary, this A 0 and B a 1 is a 1. When we got A as a 1 and B as a 0, we got a value of 2. And when we got value, or when we got 1 for A and 1 for B, the value is 3. Over here, we got just putting the values in those cells. We got 0, 1, and then we'll have a 0, 1, 0, so that's 2. A 0, 1, 1, that's 3. We skip over to here for 4. Okay. 1, 0, 0 is 4. 1, 0, 0, or 1, 0, 1 is a 5. And then skip back over to this column for our last 2, and 1, 1, 0 is 6, and 1, 1, 1 is 7. So this form, by saying that you have decimal minterms, it's easy to write summation expressions from. Then this one, I've seen people use these and put color on them, and then where you have overlapping, like if B was blue and A was red, you'd have some overlapping colors, so part of it would be purple. Here you would say these 4 blocks, there are all where A is a 1. See, A is a 1 here, A is a 1 here. Back here, A 0, A 0. So these two, A is 0. So for these 4 cells, they say this is the domain of A. This is the domain of not A. These 4 are the domain of B. Be careful, because the most, or where I see an error a lot is where somebody says here, not B. And then the domain of C. We got about a minute, so let me see what I can do. Binary, I've already showed you that one. We can put those values in it. Now watch where it changes. It changes, from going to the next column right here and from the next row right here. So we have 0, 1, and then skip 1 to 2, and then come back to 3, 4, 5, skip 1, 6, 7. Now we skip this column and say 8, 9, and skip 1, 10, and 11. And then 12, 13, 14, 15. So 15's near the middle. And then here you could say, on this last one, you could say we got the domain of A are these 8 cells. The domain of B are these 8 middle, or 2 middle columns. Domain of D is the 2 middle rows, and the domain of C is the lower 2 rows. Okay, so we should pick up what the rules are and then start doing some examples. Okay, let's see, are we all going to be here Tuesday?
Thursday.
I think so. How about Thursday? Thursday's the next time we're meeting. We should all be here. Okay, I will see you all later. Thanks for putting up with all the trouble I was having. And the DE students, I don't know how long we had, 36 minutes. Most of this time I was talking to the students about what they were doing in the lab so that I wasn't doing anything that would impact y'all. When I came back, I quickly went through some of the stuff I said that was important to you, and then started recording the whole class. So even though it says 36 minutes instead of an hour and 15, you didn't miss any of the real lecture for this class. Got any questions, email me.